Good morning, students. Yesterday we have completed our chapter number 10, vector algebra. This is also related chapter to the vector algebra. Now I am going to discuss the next new chapter, chapter number 11. Chapter number 11. The name of this chapter is three-dimensional geometry. Three-dimensional geometry. Okay, this chapter is also important. This chapter is also important for score high in your board examination. In this chapter, we are going to be learn two parts. The first part is related to the line in space. The first part is related to the line in space, and the second part is going to be plane in space. Plane in space. Okay. In standard 11, we have learned this chapter, line in plane. સ્ટાન્ડર્ડ 11 સ્ટ્રેટ લાઇન્સ ચેપ્ટર તમે સ્ટડી કરી ગયા છો. એ ચેપ્ટર્સ નું શું હતું? લાઇન હતી બટ ઇન પ્લેન, એટલે કે પ્લેનમાં જ વાત કરવાની. ધેટ મીન્સ ટુ ડાયમેન્શનલ જ્યોમેટ્રી. વી આર ડિસ્કસિંગ all the related topics, theoretical points, questions in your two-dimensional geometry. But it is line in space. This is our space. આખું આપણો સ્પેસ કહેવાય. The line in space, that means three-dimensional geometry are there. So we have to calculate all the questions related three-dimensional in your line portion. Same way, we have to discuss the plane in space, and the last portion combination of these two. આ બંનેના combine કરીને questions પૂછાતા હોય છે. ઓકે, તો એક્ઝામમાં મોસ્ટ ઇમ્પોર્ટન્ટ આ બેના કોમ્બિનેશન્સ ના ક્વેશ્ચન્સ પૂછાય વધારે મેક્સિમમ. આ ચેપ્ટર નું વેઇટેજ બોર્ડ ના વેઇટેજ પ્રમાણે લગભગ 7 to 8 માર્ક્સ નું હોય છે. એપ્રોક્સિમેટલી 7 to 8 માર્ક્સ નું આ ચેપ્ટર છે. This is coding chapter. This is very helpful chapter to get high score in your board examination. But we have to use imagination in three-dimensional space. આપણે three dimension માં imaginations થી આ ચેપ્ટર સ્ટડી કરવું પડશે. લોજિકલી જો તમે શાર્પ હશો આ ચેપ્ટરમાં તો આ ચેપ્ટર્સનો કોઈ બી ક્વેશ્ચન એટેમ્પ્ટ કરી શકશો. અધરવાઇઝ ક્વેશ્ચન એટેમ્પ્ટ કરવામાં તકલીફ પડશે. તો ખાસ આ ચેપ્ટરને લોજિકલી સમજજો અને ધીમેથી સારી રીતે અન્ડરસ્ટેન્ડ કરજો. બહુ યુઝફુલ ચેપ્ટર છે. વેઇટેજ એનું સારું છે. See here, first of all we are going to discuss about the line. Okay, what do you mean by line? For calculations of line related to theoretical points of line in space, first of all we are deciding the three-dimensional geometry. We know that there are three perpendicular, mutually perpendicular axes are there. The first x-axis, this one is your x-axis, this is your y-axis. Three perpendicular axes are there, and this one is your z-axis. Here x-axis is there. This is perpendicular to your y-z axis. This is outward side, but I can't represent it here. Therefore, I am representing like this. This is your x-axis. This is your y-axis. This is your z-axis. For proper understanding, see, this is your room. This is your room. In this room, the x-axis will becomes outward. X-axis become this. Y-axis will going to be this side. Y-axis will be going to be this side, and Z-axis will be going to upward direction. So this is your x-axis. This is your x-axis. This is your y-axis, and this is your z-axis. Imagine this thing here. This is the most important. This is x-axis, y-axis, and z-axis. Okay. Now I am going to draw the one space plane, three-dimensional પ્લેન ડ્રો કરવા 3 ડાયમેન્શનલ સ્પેસ ડ્રો કરવાનો ટ્રાય કરું છું એટલે ક્યુબોઇડ જેવો એક શેપ બને જે તમારો રૂમ છે ક્યુબોઇડલ શેપમાં હશે તો એક ક્યુબોઇડલ શેપ તમને આવી રીતે ઓબ્ટેન થતો હશે જોજો this is your cuboidal shape okay see here I am going to draw this is your cuboidal shape of your room તમારી રૂમને તમે ઝૂમ કરી શકો છો અને સમજી શકો છો this is your cuboidal shape okay of your room તો આ તમારી રૂમનો cuboidal shape છે this corner will become your origin O of coordinate axis x y and z this is your O this is your OX ray OX this is your ray OY and this is your ray OZ positive direction of x axis is here negative direction of x axis inside okay or inside the board okay this is your positive direction of y axis this is your negative direction of y axis this is your positive direction of z axis and the negative direction of z axis will be our downward side clear આ લોજિક આપણે ચેપ્ટર સ્ટાન્ડર્ડ 11 ના 3 ડાયમેન્શનલ જ્યોમેટ્રીમાં બી સ્ટડી કરી ગયા છે એટલે આ ફરીથી એકવાર રિવિઝન પોઈન્ટ ઓફ વ્યૂ થઈ now I am taking one line in space like this is your line so this line will make some angle with this line makes some angle with the positive direction of x axis y axis as well as z axis this line will make some angles with the positive direction of x axis y axis and z axis suppose it will make the angle with positive direction of x axis the line will make which makes the angles with this line is known as capital L. I am assuming the name of this line is capital L or small l. We can represent by capital L as well as small l. The angles with positive direction of x-axis means OX, OY and OZ are alpha, beta and gamma. This line will make the angle with the positive direction of x-axis is alpha, with the positive direction of y-axis is beta, and with the positive direction of z-axis is gamma. This line will make the angle between positive direction of x-axis is alpha, positive direction of y-axis is beta, and positive direction of z-axis is gamma. Then we can write down the position vector in the direction of L is given as L bar is equals to I am taking the vector in the direction of line L which is also denoted as L1 L2 L3 is the directional vector of line L I am taking L bar which is equals to L1 L2 L3 is the directional vector of line L. Then we can calculate the direction cosines of line L are cos alpha which is equals to L1 divided by magnitude of L bar, cos beta which is equals to L2 divided by magnitude of L bar and cos gamma, which is equals to L3 divided by magnitude of vector L here. Cos alpha, cos beta, cos gamma are the direction cosines. The direction cosines can be also written as L is equals to L m n ના ફોર્મમાં બી લખાય. તો L is equals to L1 upon magnitude of vector L. M will be L2 divided by magnitude of vector L, and n will be equals to L3 divided by magnitude of vector L. Okay, this is the directions cosines L, M and n here. Now we know that the result L square plus M square plus n square, which is also equals to 1, same as we also know that cos square alpha plus cos square beta plus cos square gamma, which is equals to 1 here. But we know that the line has two directional vectors. We can take the line has two directional vectors. First one is in this direction, means in direction of L bar, and we can take this direction L bar, and the opposite vector also minus L bar. So the direction of line may be different, but direction vectors આવશે. First one is L bar and second one is minus L bar. એ બી તો કહેવાય જ ને, આ ડાયરેક્શન કરો લાઈન ને કે આ કરો, બંને એક જ વસ્તુ છે. લાઈન is going to be continuously infinite from two sides. બંને સાઇડ્સ થી બંને બાજુ ઇન્ફાઇનાઇટ સુધી જાય છે, એટલે એના બે ડાયરેક્શનલ વેક્ટર્સ આવશે. ફર્સ્ટ વન ઇઝ L bar, second one is minus L bar. If we are taking the direction of line which is equals to minus L bar, then we are getting minus L1, minus L2, minus L3 here. Then our direction cosines of line L will becomes minus L1 upon magnitude of L1, cos beta is equals to minus L2 upon magnitude of L bar, and cos gamma is equals to minus L3 upon magnitude of L bar. Now we are writing down this. See here. Okay, therefore we can calculate it like this. See here, if the direction of line will be taken as the direction vector of line L bar is given by minus of L1 minus of L2 minus of L3, then it will becomes the direction cosines of line L are given as cos alpha equals to minus L1 upon magnitude of vector L, cos beta is equals to minus L2 upon magnitude L, and cos gamma, which is equals to minus L3 upon magnitude of vector L. Here cos alpha is equals to L, therefore we can write minus L1 upon magnitude of L, m is equals to minus L2 upon magnitude L, and n is equals to minus L3 upon magnitude of vector L here. Okay, but the direction angles here cos alpha equals to negative, therefore we can say that the angle made by this line with the positive direction of x-axis will become pi minus alpha. Second, with the positive direction of x-axis will becomes pi minus alpha, with the positive direction of y-axis become pi minus beta, and with the positive direction of z-axis become pi minus gamma. In this case the angle made by the line will the line are pi minus alpha, pi minus beta, and pi minus gamma with ox, positive direction of axis, oy and oz respectively. A case માં તમારા angles with the positive direction of x axis, y axis and z axis will becomes pi minus alpha, pi minus beta and pi minus gamma. Okay, તો એ કેસમાં તમારા એંગલ્સ ચેન્જ થઈ જશે. એટલે આ વેક્ટર્સ, આ લાઈનની ડાયરેક્શન્સ બે પોસિબલ છે, એટલા માટે તમારા ડાયરેક્શન કોસાઇન્સ માટે પ્લસ ઓર માઈનસ પોસિબિલિટી છે. સેમ વસ્તુ આ L1, L2 અને L3 ને શું કહેશો? તો હિયર L1, L2 and L3 are known as direction ratios of line L. L1, L2 and L3 are known as direction ratios of line L here. Clear? So this is the topic related to directions cosines of line L here. It will become cos alpha equals to plus or minus L1 upon magnitude of L bar, the direction of line. Cos beta equals to plus or minus L2 upon magnitude of alpha, and cos gamma which equals to plus or minus magnitude of L bar. આ બંને કેસ મેં કમ્બાઈન કરીને લખી દીધા છે. ક્લિયર? તો તમારે કોઈ બી લાઇનની પરફેક્ટ પર્ટિક્યુલર ડાયરેક્શન્સ એન્ડ એંગલ ઓર angle made with the positive x axis, y axis and z axis are given, then we can calculate the directions cosines easily. Okay, તો આપણે એને રિલેટેડ હવે ક્વેશ્ચન્સ થોડાક જોઈએ. ચલો, રાઇટ ડાઉન ધીસ ટોપિક. Now we are going to discuss some questions related to directions cosines and direction ratios. Exercise 11.1 question number 1 is that if a line makes angle 90 degree, 135 degree, 45 degree with the x, y and z axis respectively, then find its directions cosines. So here a line makes angles with the x, y and z axis, with x, y and z axis are 90 degree, 135 degree and 45 degree respectively. Therefore alpha equals to 90 degree, beta equals to 135 degree and gamma equals to 45 degree. Therefore cos alpha, which will become cos 90 degree, which is equals to cos 90 0, cos beta, which will become cos 135 degree, will be calculated by use of 90 plus 45 degree. So cos 90 plus 45 sin 45, and second quadrant is there, cos is negative in second quadrant, therefore it will become minus 1 by root 2, and cos gamma, which will be calculated by cos 45 degree, which is equals to 1 by root 2. Therefore the required direction cosines of line are, so that's that 0, second one minus 1 by root 2 and 1 by root 2. Cos alpha, cos beta and cos gamma are the directions cosines. It is quite easy question. Now see the next question, exercise 11.1. Question number 2 is that find the direction cosines of line which makes equal angles with the coordinate axis. Here line makes equal angles, here line makes equal angles to the coordinate axis, with the coordinate axis, okay, with the coordinate axis. Therefore we can say that alpha will becomes equals to beta will equals to gamma here. Now the result relation between cos alpha, cos beta and cos gamma is given here. Cos square alpha plus cos square beta plus cos square gamma, which is equals to 1. Beta and gamma also equals to alpha, therefore we can write it cos square alpha plus cos square alpha plus cos square alpha equals to 1. Therefore it is equals to 3 cos square alpha equals to 1. Cos square alpha equals to 1 by 3. But here cos alpha will become plus or minus 1 by root 3. This is not vector, this is line. Therefore we have to take both the values plus as well as minus here. In vector we are taking only one value, but in line we have to take both the values plus or minus 1 by root 3. Therefore the required directions cosine, of line, cosines of given line are plus or minus 1 by root 3. Second, cos beta, which is also equals to cos gamma, which is also equals to plus or minus 1 by root 3 here, because they are equal. Therefore we can write the directions cosines plus or minus 1 by root 3, plus or minus 1 by root 3, and plus or minus 1 by root 3. Okay, so these are the directions cosines plus or minus 1 by root 3, plus or minus 1 by root 3, and plus or minus 1 by root 3, for which the line makes equal angles with the coordinate axis. Alpha equals to beta equals to gamma. Okay, now we are going to discuss the next question. Question number 3 of exercise 11.1. If the line has direction ratios minus 18, 12, minus 4, then what are its directions cosines? આના જેવો જ એક સિમિલર ક્વેશ્ચન એક્ઝામ્પલ નંબર 2 છે, એ તમારે સેલ્ફ જાતે કરવાનો છે. હમણાં આગળ ક્વેશ્ચન્સ 1 ની સિમિલર ક્વેશ્ચન એક્ઝામ્પલ નંબર 11 એ બી તમે જાતે કરશો. એક્ઝામ્પલ 1 and example 2 you have to do in your self practice. Here it is given that the line has direction ratios. So direction ratios are given here. So what are the direction ratios? So direction ratios are given here minus 18, 12, minus 4. So direction ratios means L1 equals to minus 18, L2 equals to 12, and L3 becomes minus 4. Now direction cosines are given by cos alpha equals to L1 divided by magnitude of this L vector which equals to minus 18, 12 and minus 4. That means under root of L1 square plus L2 square plus L3 square, same as cos beta which is equals to L2 divided by under root of L1 square plus L2 square plus L3 square, and cos gamma which is equals to L3 divided by under root L1 square plus L2 square plus L3 square. You have to put the value of L1, L2 and L3 in this directions cosines. Then we will get the value of cos beta, cos gamma and cos alpha. Then we can write the direction cosines of the given line R. જે આવતી હોય તમે લખી દેજો. ઓકે, એ કેલ્ક્યુલેશન્સ તમારા પર છોડું છું, એટલું તમને કરી શકશો. નેક્સ્ટ we are going to discuss example number 4. In the example number 4, find the directions cosines of x, y and z axis. We have to find the directions cosines of x axis, y axis and z axis. Here three axes are there. We have to calculate the first of all directions cosines of x axis, y axis and z axis. ત્રણેય axis ની directions cosines calculate કરવાની છે. First of all, we are going to discuss the directions cosines of x axis. Okay? So for the directions cosines of x axis will become, જો એની directions cosines જ્યારે x axis ને calculate કરવી હોય તો first of all we have to obtain the angle made by x axis with the positive direction of x axis, positive direction of y axis and positive direction of z axis. Here x axis makes angles with x, y and z axis are first 0 degree with the x axis. X axis makes 0 degree with the x axis. X axis પોતાની સાથે કેટલો એંગલ મેઝર કરશે? 0 degree. X axis makes 90 degree with the y axis. X axis makes 90 degree with the y axis. 0 degree, 90 degree with the y axis, and x axis makes 90 degree with the z axis and 90 degree with the z axis respectively. Therefore, direction cosines of x axis are cos alpha, cos beta and cos gamma. So cos alpha, that means cos 0 1, cos 90 0 and cos 90 will become 0. So the directions cosines of x axis are 1 0 0, same as direction cosines of y and z axis are 0 1 and 0 and 0 0 and 1. Okay, see here the y axis which will make the angle with the positive direction of x axis will 90 degree, with positive direction of y is 0 degree and with positive direction of z is 90 degree. The 90 0 90, alpha is 90, beta is 0 and gamma is 90 for the y axis. Therefore, the directions cosines cos alpha, cos beta, cos gamma will be given as cos 90, cos 0 and cos 90, which will become 0 1 and 0. Same as z axis makes an angle with the positive direction of x axis is 90 degree, with the positive direction of y axis is 90 degree and with the positive direction of z axis is 0 degree. Therefore, alpha equals to 90, beta equals to 90, gamma equals to 0 for the z axis. Therefore, the directions cosines of z axis are cos 90, cos 90, cos 0, which will become 0, 0 and 1 here. मैं डायरेक्टली राइट डाउन कर દીધું છે, તમે કેલ્ક્યુલેટ બી કરી શકો છો મેં જે તમને એક્સપ્લેન કર્યું તે રીતે. ચલો તો આજના વિડિયોમાં આપણે લાઈનની વાત કરી, એમાં બી ડાયરેક્શન્સ કોસાઇન, ડાયરેક્શન્સ રેશિયોની વાત કરી. તો આજનો વિડિયો બહુ ઈઝી અને અન્ડરસ્ટેન્ડેબલ છે. તો આજનો વિડીયો લાઈક કરો, કમેન્ટ કરો અને અમારી ચેનલને સબસ્ક્રાઇબ કરો. થેન્ક યુ વેરી મચ. આજે આપણે આટલું રાખીએ છીએ.